Hey everyone, this is another part of the parallel cryo-electron tomography or PACE-tomo tutorial, and in this video I'm going to show you how to select PACE-tomo targets on a cryo-fit milled lamella. So I just loaded my grid and I took a montage of this lamella, which is quite contaminated, but it will do just fine for this short little tutorial. So what you first want to do is, of course, find the eccentric height on your lamella. And in my case, I took a montage. The montage is not strictly necessary, but it helps you because you can easily select targets via the navigator's add points function. And then you go around and pick targets of interest on your montage. So the first target is the important one. That's where most of the tracking will happen. That means that this target will still give you data and will still provide you with a tomogram with only one additional autofocus exposure. However, the tracking will be a little less precise, so you might lose a bit more field of view, just to be aware of that. So I wouldn't use my favorite target for the very first one. And another thing to keep in mind is if it loses the first target, if the tracking doesn't work on that one, it will lose all the targets. So it should be some feature that has some contrast. Let's, for example, use this multilamellar vesicle here. That does not seem to be subject to any big ice chunks coming in already at low angles. All right, and then from there, let's just browse around the lamella a bit. Maybe I'm interested in this vesicle feature here. Maybe I want to see some of these ribosomes. There's some interesting looking vesicles here, and maybe one more around here. Of course, you can be arbitrarily selecting these points. And also, this is just a preliminary selection. So during the select targets procedure, you can still say, oh no, this one wasn't as interesting as I thought, so I'm going to skip this one. And of course, I just picked 5 targets here now. You can pick 20, 30, however many you wish to collect. Once you're done, you just click Stop Adding, and then you have this group of points here. And it's important that this is a group of points added in one go. That means that when you collapse it, it will be just one group of 5 items. All right, this is a neat little trick. If you have the last point selected, you collapse and uncollapse, it will select the first point. And that's quite important. You need to select the first point of the group before you run the select target scripts. So the select target script is called PACE-tomo select targets. And this is version 1.5. Things might change if you are on a future version. I'll try to mark any changes as not discussed in the video tutorial in case they happen. But here are some basic settings. So if you're just starting out, you definitely want to set guidance to true because it will give you an explanation of every step and have lots of little pop-up message windows that explain what you have to do. Target by shift is something you can use if you don't want to drag around. You can give it fixed values of image shifts that you want to have between your targets. This is nice if you want to have like a semi-ordered pattern of acquisitions or of targets on your sample. But I'm also not going to use this right now. And these other settings are also not really important for what we are going to do. This is for collection of target patterns on, let's say, a Holy support film. And these ones are quite useful. This actually makes it possible to temporarily plot the beam diameter on your view image over here. And this will become quite useful to judge how close you can actually pick targets to each other. But it is important that you only set this beam diameter to 0 if you are using a Thermo Fisher microscope that has the illuminated area property, because SerialEM will use the report illuminated area command to figure out the beam diameter. On, let's say, a Joule or maybe some other older microscopes, you will have to set your beam diameter manually and maybe read it out from the microscope interface. The max tilt is basically how the beam is going to be stretched perpendicular to the tilt axis to simulate what area would be exposed at this tilt angle. I usually just stick it to 60, so the dimension perpendicular to the tilt axis will be scaled by 2. All right, and with that, we can actually go and run. So first things first, it will remind you to uncheck the move stage for big mouse shifts check mark. And this is important because otherwise when you drag from target to target, it will actually apply a stage movement. This will mess up the relative image shift determination. And we see here, I do actually have it checked. So no, I do not want to proceed with the script. So I'm going to uncheck that and I'm going to run it again. All right, this time we can say yes. And then we'll have to choose a folder where all the files will be saved. And I usually just have my main grid folder, which in this case is called PACE tutorial, and then I have a subfolder called PACE, and I'll just select this folder. A little caveat here is that unfortunately the text file working directory and the directory where you saved your frames is the same. So what you should do is set up the folder where you want to save your frames, then run the select target script, choose your folder here, and then don't change the frame folder again unless you have to, because otherwise you'll get a pop-up telling you that you are in the wrong folder when you actually run the PACE-tomo script later on. Anyways, and then it will detect if the point you currently selected is in a group of points. And if it is, you can choose to use this group of points as target templates or initial target positions that will be refined during this procedure. If you select no, or if the selected navigator item is not a group of points, it will just let you drag wherever you want to go. But it's quite nice to already let the script get you in a roughly the right position, and you only have to drag a little bit to refine the position rather than drag from one point all the way to the next point, all the way to the next point, and so on. So yes, we're going to use this group of points. Then it reminds you again, please make sure it's the first point of the group that is selected, and this is what we checked before. And there's 5 points in the group, which sounds right, so we're going to do that. And then we have to provide a root name for the PACE-tomo collection area. This has to be a unique name. It will basically be the name of all the tilt series, but also the file containing all the data about the different targets. And this is, in my case, the third lamella on this grid, so I'm just going to call it L3 and hit OK. Now it will move to the first selected point and take a view image here. And then it will remind you that you're supposed to drag with the right mouse button to your target. And once you're done, you just press the B key on your keyboard. So you can take all the time you want. You can center it really nicely. You can drag it several times. And then once you let go and you're happy with it, you press the B key on your keyboard. And then it will ask you if you want to take a preview image here. And then you say yes if you're happy. And once the preview image is taken, you can see the image shift is not quite centered here. So it asks you to refine. Do you want to refine the position at this mag? If you click yes, it will ask you again to drag with the right mouse button. And once you're done, you press the B key. So let's center this properly. And maybe I'm gonna use the console to apply a bit more the focus to make sure there's enough contrast to actually realign to it. Although this will also work. But I'd like to see my features in the target preview image. Okay, I'm done. I hit B. It will take another preview image. There we go. And then it will ask you if you want to save the current image and the coordinates as your target number 1. And we hit yes. It will save this target image as a map in the navigator. It will also take a view magnification image for the realign to target procedure later. So we wait until that is done. And then it will move to the next point. Oh, you can already see this is the beam diameter plot. So it took the beam diameter from the illuminated area and it stretched it by 2 perpendicular to the tilt axis to give you a rough idea of what area will be exposed throughout the tilt series on this target. Now we arrived at the next target. Once again, you center it and you hit B with finished. I am interested in this vesicle here. So this is not always precise as you saw, it's a bit off. That's why you have to drag and refine it. We hit B. We do want to take a preview image. If you hit no, when it asks you to hit a preview image, it will take another view image and give you another chance to drag. All right, let's refine it a little bit. Oh, once again, we drag, we hit B. It will take another preview image and then it asks you if you want to save it. If you hit no here as well, it will also go back to the view magnification, take another view image. It will also ask you if you want to skip this point of the group. Maybe let's try this for the next one. Do you want to add another target? Yes, we do want another target. Okay, we arrived at the next point. So let's hit OK. Say we want to be taking an image of this vesicle here. Hit B. Do you want to take a preview image? Yes. But we can see already that there's quite a few ice chunks left of it that will probably come into the field of view during tilting. So let's say we realize this and we change our mind. Oh, we don't want to take an image here after all. Or we take a preview image and see, oh, this feature is not what I thought it was in the low magnification mode. So when it asks me if I want to save it, I'm going to say no. It will ask you, oh, do you want to skip this point of this group? Once again, if you say no, it will just stay at the same spot, take another view image, let you refine it. But if you do want to skip it, you click yes, and it will move on to the next point. All right, next point. It's already nicely centered. So let's go to the next step by hitting B. Yes, let's take a preview image. We're going to save the last target, and then it will tell you that all the points of the selected group have been viewed, but you can also add another target manually. And that means, let's press yes here, and that means it will take a viewer image, but it will stay over the last target at the same spot, and then you can manually drag it over larger distances to maybe find other targets close by. All right, back to the dragging. So let's say, oh, there's a vesicle down here. So let's center this, hit B. And actually, since I dragged quite a long ways, I don't want to take directly a preview image, but I do want to keep looking for a target. So let's take another image here. So it moved a bit, not too bad, but just recentering it. B, let's take a preview image here. Yes, refining. And save it. Okay, do we want to add another target? Okay, let's try it again. Let's say we go back to view mode, we look around a bit more, but as we drag around, we don't find anything else interesting. So what to do now? So first of all, you hit B. Do we want to take a preview image here? No. Do we want to keep looking for another target? No. All right, and this finishes the target selection loop, and it will open this target user interface here afterwards. It's like a separate window, and there's all kinds of options. Let me just say that if you don't want to edit your targets at all, you can just close it and you already are ready to collect PACE-tomo. But this interface will allow you to manipulate your targets a little bit and also get a better overview. So first of all, on the top left, you can see a list of all your targets. You have target 1, 2, 3, 4, and 5, and you have the image shifts that are being applied. If they're getting too large, let's say more than 15, I think can become problematic. So it's nice to have an overview over how much they are. You can also say, oh, let's have a look again at target number 3. So I can open the target file. You have to have 3D mod or something installed for this to work. And you see, oh, this is maybe not what I wanted. And you can say, I don't want to collect a tomogram here. So just set it to skip. And then it will turn gray in the plot and it will set skip to true. So this plot actually shows once again the targets according to their number with the image shift in X and Y. So this is the tilt axis and those are all your targets. Instead of selecting and hitting skip, you can also just right click it here. You can skip all the targets except of course the tracking target, which you cannot skip. So this is quite an easy way to skip certain ones. If you double click on one, it will also open the target file, so you can also get a quick look. What you can also do is you can toggle the beam, you can get a beam diameter estimation. In case your plot here doesn't align with the way serial EM shows the map, you can also swap the axis to make it fit to get a better overview. Because unfortunately you can't see the features directly in this plot, you still have to refer to this overview image. And for this purpose, you can also use the load map function. So I know that I have taken a montage, this one here, number 25. So if I want to have this visible again, I can just load map 25, and it will load the map again in the overview here. Unfortunately, when you load a montage or a stitched map, it will screw up the beams a little bit. But at this point, you're done selecting your target, so it doesn't matter so much. All right, a couple more features that this allows you. If you had already a tilt series file, you could open the tilt series file. What you can do, you can say, oh, maybe this tracking area was not a good idea after all. Maybe I want to use number 4 as a tracking area instead. You can hit make track, and it will actually realign to this target, calculate the image shifts from this position to all the others, and then make this the new tracking area. But this might not work completely well if it cannot align nicely to the target. So if you do this, you should always check here if the alignment works nicely. Another function is save views. I'm actually going to do that. So what it does is it goes to every target and takes a view image, saves it, but also saves it with the overlay you can see here. So once you have your tomogram, you can go back after reconstructing and see maybe the bigger surroundings to get an idea of the context of your tomogram. This is something that can be quite useful, but what might be even more exciting is once you do this, you save all the view images of the targets that you collect, you can maybe further down the road use all these view images that you have already collected over several tens of sessions, let's say, of PACE-tomo acquisition to train a neural network to automatically find your features of interest in a montage like this. Maybe this might be something for the future, and this might be a motivation to already go now and save the views. So let's try this out. Whenever you click a button here, you can see it stays depressed until it is done, but you can also just follow serially along and see, of course, down here what it is doing in a moment. All right, once it's done, we can go back to the user interface and look at some of the other functions. So there's a reorder function. In case you prefer to collect the targets in a different order, you can drag them around here in however order you want, and then you can click reorder and it will reorder them according to that. If you don't want to keep these settings, you can set reset, but there's an option if you want to. And then, of course, you can actually save the settings to the targets file, and it will overwrite your targets file with everything you did here. Otherwise, if you close the GUI, it will not save the changes. More interestingly, you can also set the settings here that you would normally set while running the PACE-tomo script. And this will override whatever settings you do in the script. And this can be useful because if you run PACE-tomo in batch, it will apply the same exact settings to every single target area. However, if you want to have unique settings for different target areas, you have to define it in the targets file. You can set things like start tilt angle, minimum maximum angle, and increment, but also this is the geometry parameters, and they are of course quite important for PACE-tomo to predict the movement of the sample. For the lamella, this is usually something like, in my case, -9 or -10 degrees, and then the rotation, which is the rotation relative to the tilt axis. And as you can see, you always try to load the lamella perpendicular to the tilt axis, but it's never quite perfect, so we have a bit of an additional rotation here. And to figure these things out, you can actually do it straight from this interface. So it takes a bit of practice. Let's load the montage again. So what you can do is to determine the geometry of your lamella, or just your sample in general, you can measure the defocus at different points on your lamella, and then you can fit a plane into this cloud of points, and you get an estimate for your pre-tilt and rotation of the lamella. And surprisingly, this is not always just the exact degree amount that you use for the fit milling procedure. Sometimes it's off by 1 or 2 degrees. Especially if you have a crack like this, the lamella might be sagging sideways. This will also throw off this value a little bit. So let's try this here. The way you do this is you middle click inside this plot to create another point. And once again, it's important to select points that don't overlap with your targets, otherwise they will already get exposed by this autofocus procedure. But it's also important to choose points that are not in like a dark area or an ice chunk that will throw off the estimation of the defocus. So that's why I like to reference both the graph and the actual montage here when I select these points. So in between these points should be fine. And even further down the road, I'm going to collect one more here, maybe one here, and then maybe one here. So I usually like to take 5 points. The more points, the more accurate, of course. 3 points is the minimum to estimate the geometry. And then you can just click measure geometry, and it will go to all these points and do a quick autofocus. And it will tell you, of course, the autofocus it measures down here. And then it will also tell you the pre-tilt and the rotation once it's done. All right, here we go. We got an estimated pre-tilt of -8 degrees and an estimated rotation of about 12.5 degrees. And that seems very reasonable to me. Once again, let me quickly load the montage map. This is a workaround because you cannot load montages while you are running a script. So I had to come up with a little bit of a workaround to load the montages. And you can see it does make sense. Like there's probably between 10 and 20 degrees of rotation clockwise of the lamella versus the tilt axis. So this value seems reasonable. -8 is also close. My target milling angle was 9 degrees, so this is close enough. And I will be using these values. So I hit save. I'll overwrite my targets file again. And once I'm happy with everything, I can just close the window and it will tell me target selection completed, 5 targets were selected. So the interesting part about this editing targets GUI is you can also open it after you're already done. So if you select your main target, which is the one that has the target file text file name in the node and is marked as the 001, and you run the select target script on it again, Okay, of course, it will ask you if you have the move stage for big mouse shifts activated, which I do not. It will ask for the folder, and if it does find the target file in this folder, it will actually ask you, oh, there is already a targets file attached. Do you want to edit these targets? And you can say yes, and it will actually load the GUI again. And then you can go back, change the tracking area, you can add new targets. If the stage was moved, it will first realign to your target number 1 and then go back into the target adding loop. And once the loop is finished, it will open the GUI again to edit things. You can see it saved the pre-tilt and the rotation. It does not save the geometry measure points. You have to do those again if you want to check again. Yeah, but that's about it for the target selection on a Lamella sample. So let me know if you have any questions or if you run into any issues. This GUI, of course, is a bit more involved than just a simple serial EM script. So depending on your setup and how you combine certain functions, you might still run into some bugs that I haven't encountered. So if you do so, please let me know on the issues tab on the PACE-tomo GitHub page. And next up, you might want to watch the PACE-tomo acquisition tutorial video. Thank you so much.